make sure this mic works. Okay. Hi, I'm happy to be here. So my name's Jasmine, and today, I know this is a very popular topic, so I tried to, write it out just to make sure that I don't go on tangents, because there's quite a lot. And what I will be discussing today is GPT-3 and other language models in the context of XR. And so our community has long dreamt of a VR holodeck or scenario where we speak worlds into existence. And in this talk, I'll explain why there's quite a lot of intermediary steps to execute before we can even get to an implementation of a holodeck. And so as a Trekkie myself, even though I enjoy the holodeck reference, I wanted to show a more contemporary reference, and that's the Hunger Games from 10 years ago. And so this scene was the control room for the arena, and similar to the holodeck, the actual arena was confined to a physical area, and the game makers could spontaneously create, they could create force fields to like sequester parts of the arena. They can control weather and generate hazards, and so if you haven't seen Hunger Games, I actually think that's a good reference. Not the dystopian part of Hunger Games, but the world generation aspect of Hunger Games. And so I can't make the assumption that people that are interested in XR are familiar with AI terms specifically, so excuse me if it seems like I'm sort of starting at step one. And so this is kind of just what we'll go over. And so I'm going to define some AI-specific terms, and then I'll provide sort of a realistic, maybe sobering take, sorry, on the current progression of large language models in the context of VR, and then I'll ramp back up again to hopefully provide a positive note to what can actually be accomplished. And so I think this is kind of a point of confusion with people, is like, what's a model? And as we know fondly from Twitter, the XR community has like its own set of jargon and terminology, and the AI community has their own terms, but they're actually more fixed and less debated, which is good for them. And so the way that I like to just simplify what a model is just from a high school algebra example. So everyone hopefully is familiar with the slope-intercept form of a line. And so that's an algorithm. So that's what we do to attempt to solve a problem, whereas the actual y equals 5x plus 10, that's an equation that provides one solution. And if you remember from statistics, you can have a bunch of data, then you use that line of best fit, and that's the model. And so, yeah, I mean, that's exactly how machine learning works. And I think one interesting thing is that you can use the same algorithm with different data or a different model with the same data, and it would produce a different model. So GPT-3 is a very specific model. You can make your own model as well with their same data, although they have access to more data than you probably do because of their partnerships. And so that's something to keep in mind, that the quality of models is heavily reliant on data. And so that's a very important thing to know. And then also, I think there's sort of this misconception that size is better. So I think humans have about, I think it's 86 billion neurons. And so people assume, let's have it match, what the number of parameters that humans have. But just because something's bigger doesn't mean it's necessarily better, because you still want things the data to be tagged properly, and you want models to be pre-trained. And so specifically, I wanted to talk about OpenAI's models. So I hope everyone's familiar with OpenAI, which I think they are. So it's a research lab that was founded by our favorite almost owner of Twitter, and then Sam Altman, Brockman, and Ilya Sutskever, and one other. And so OpenAI has their own set of models. And like I said, again, they have access to like billions of data parameters, but again, you could make your own model. So this is just what they output. And so the first one that everyone knows was GPT-3, and that was actually released 2 years ago in June 2020. And so it uses deep learning to generate human-like text, and then that text can be interpreted into a variety of formats. And the one that really caught traction in our community was DALL, which generates images from natural language descriptions. But the one that I'm going to focus on for the last part of the talk is Codex, and I think that one was very understated, and it's sort of I would say it's like a sibling of GitHub Copilot, and it parses natural language to generate code. And so while OpenAI has their own solutions. I just want to reiterate that Google has Lambda. Microsoft and NVIDIA actually have their own model. It's called Megatron Turing NLG530B. So that actually does sound like Star Trek, so I'll give them credit for that. And so these are, because the thing is, I think what happens is when people make graphs, they sort of get confusing, so I hope this is parsed decently. So what this is it's not necessarily the applications, I put those separately, it's the models. So like we said, the model is just like the equation that generates something. And so the thing is, these are all of the image models that I found. There are obviously going to be more. You can add to this too, or your startup. There's video. We do have 3D, so Get 3D with NVIDIA, Dream Fusion, Google, and we have Clip Mesh. There's now audio models and text. And the thing is, because the text, GPT-3 hasn't been around for a bit longer, there are a large amount of text-based apps. Like I know that Jasper AI, which I think generates marketing content, got like 150 million in funding recently. So yeah, I mean, that's just something to think about. And so I think this is important to know, okay, well, what can we actually do now? And so I think this was like a way that I wanted to put it, is that right now we can generate image outputs from DALL, MidJourney, Stable Diffusion, or any of those other models. And so what we've seen is that you can apply them to VR technically, because what you can do is you can use that, and that's actually a Portuguese pattern tile. I thought that was appropriate for where we are. And you can actually use that mapped as a UV texture to apply to a model. So I've seen someone do that. And then this one is you can take the image output, you can make it patterned and rectilinear, and so you can use it as a VR environment for people to be able to stand around in. And so the problem is, you can say, I've seen really cool demos on Twitter, so maybe you're just being a buzzkill, or like maybe we're closer than we think. And like I would say that in the same way that people take 20 selfies and they post their most flattering ones, there's so many flawed results with current models. But the thing is, when you're trying to drive engagement to your profile, you're not going to post the ugly results, right? And so I kind of want to state a trigger warning for those who are sensitive to Uncanny Valley. So the next slide is a bit creepy. To me, it was creepy. So yeah, what we want is, we thought that we were going to generate, so this is actually in MidJourney, so I did not install OpenAI on the record. So this is clownfish, so the prompt was clownfish, sea anemone, and realistic. And this is what we wanted. We wanted something that looked like Nemo, and that's sort of what we expected, but that's actually what we got. And I find that really creepy. But what I can see from that is that the model is prioritizing color, and it's prioritizing texture over the actual form. And the thing is, what I've noticed is there's a tendency for non-human living beings to be distorted because there's far more training on human face data, right? We're very egotistical creatures, so we don't have other animals' faces embedded within these models. Yeah, also one thing to note is that the art actually, I would say, performs even better than the text in some situations because of data. So if we think about data, when it comes to, we'll see this later, when it comes to programming, we only have like 60 years worth of programming, modern programming languages. We have like 1,300 years of English, whereas art is like a staple in like human exploration and being. And even still, it's still not there. And so when we want a holodeck, we need something that has real-time interactivity, and it has to be multimodal, and it has to have full user agency. And so this is just something that I think is that standalone 3D animations that don't influence other objects, they're sort of non-narrative, right? Which means that like they won't influence anything. They're just sort of there. I mean, even NPCs actually can impact something, but you can't just have random or random animated assets in a scene and like expect that to really do anything. And so similarly, if we just like use Get 3D to generate models and say like, I want a horse, I want a chair, I want this, even if they're just static, it's basically just essentially a digital sculpture garden and exhibit. And you know, us in XR specifically, and gaming specifically, aim towards interactivity. And so this is kind of how I see the difference between what we have now versus where we need to go. which is that what differentiates AI-generated art from the holodeck is that the behaviors need to be explicitly scripted or suggested, even random behavior. Like you would have to know when to introduce randomness into a game or into an experience. Whereas like an AI-generated art, what makes it appealing is that originality actually emerges when you have unexpected outputs, right? And so another way that you can look at this is like what we've seen that gets a lot of traction, they're sort of machine hallucinations, but we want human-willed hallucinations. I want to choose what I see. And so there's a lot of issues why. So I'm actually going to tell you why. And that's the benefit of research, because it's not product-based, this is just where we are. And if anyone can help, please help with what's going on right now. And so there's a huge difference between real-time coding versus compositing, right? So what we've seen mostly has been heavily composited in the sense that we have to use external software outside of the applications that the models are running, then put them in and stitch them together, and then make a demo so that like our app or prototype gets traction. And so a bulk of the processing is done offline. But the issue is what would need to happen is that users would need to be able to write code, pseudocode, give instructions, and then have both compile and execute runtime. And that's where the issue lies. And I actually will agree with the gentleman who was here before me, because that's actually one of the benefits of why web integrates so well with OpenAI models versus game engines that we're accustomed to. And so again, this is just the difference between things that are at compiled time versus runtime. And so what we're trying to do is we have to have a runtime and compiler that can compile C# code while we're in Unity. So it's a nested process, and that's again not very easy to do, but I'll explain that a little bit later. And so like I mentioned earlier, one of the solutions is Codex, which translates simple English instructions into a dozen popular coding languages. I want to note that I don't think that's necessarily a good thing, because there are obviously other important languages, important spoken languages that we have, but for now it was trained in English. And so you can actually turn comments into code, you can call useful libraries, and you could even rewrite code for efficiency, and there's just a whole host of other things that you can do. And similar to DALL-E, the way that you sort of instantiate it to work is you comment. So again, I try to be positive about this. So the first problem of Codex is that it's still in closed beta, which means that you have to go on the OpenAI Codex portal and apply to even get access to it. So that's step number one. Step number two, which you'll see later, is there's a lack of C# training data, because I'll explain where it's taking the data from, and I'm sure if any of you have looked all over GitHub, even though technically, Microsoft did make C# in like 2000, there's not really a lot of C# code publicly available. And then the other issue is that there's a limit to the amount of context you can pass. So the issue with that is like sometimes, like if you look on the bottom example, if you look at the top example, it's fine. I tell Unity, generate an object, rotate it, fine. And because it's a primitive object, Codex can figure out how to do that. But then when I say when two objects collide, print something to the console that says wham, the problem is it's assuming objects that aren't there. Like those objects aren't instantiated. So what you would actually want to do is comment what objects you're trying to actually have collide. And then the problem is there's like a 40-line or so limit to what you can do. And then again, these are simple examples, and so there should be an expectation of general implementations. And so yeah, this is a lot of people don't realize that a lot of the data that's taken to train Codex is from our favorite hosting service, GitHub. And so the thing is, when you look at GitHub, you see this. I mean, this was from 2 days ago. This changes, but it's the general trend where C# is all the way over there. And so the thing is, that's why the models work best on Python. They work very well in Java. And you say, we'll get to this the next slide. You say, oh, well, C++ is there, and I know that I can use C++ with Unreal, but Unreal presents another problem, which makes it difficult to integrate OpenAI's API. And then we see JavaScript there, which makes it a good contender. And then we have everything else, and then we have lonely C# over there, which is what we want to build in. And so yeah, this is kind of a breakdown, at least this is the best I can come up with of like what the issue actually is. And so the thing is, I would say, this is just an opinion, that these are probably the 3 languages that people use when they're making games or environments. So JavaScript, C#, and C++. And I did that in order of like casual to AAA games, right? And so the thing is, with JavaScript, we have a lot of interactive software. We have Babylon.js, which Microsoft has, and we have 3JS, which Google has. Then we have derivatives of 3JS, which are A-Frame. We have WebXR and their derivatives called FrameVR. And the thing is, we can access all of the JavaScript pipeline because OpenAI itself on their GitHub, they have an OpenAI Node.js library. That's why a lot of the examples are using JavaScript, because it's already, the functionality is already there. So the issue is with Unity, as we move this way, Unity uses C# in a mono-development environment. The problem is we do have, and these aren't OpenAI solutions either. These are indie developers who wanted to make a C# wrapper so that it can actually interface with OpenAI. And so there's a lot of OpenAI APIs on GitHub. But then, like I mentioned before, because it's not supported, you need something to be able to compile C# code runtime in Unity. And fortunately, there is a Roslyn C# runtime compiler. And in the case of Unreal, even though there is an OpenAI API, there's no public runtime compiler for C++. That's why, even though we want to see that, and also I've been thinking about this, and I've seen people ask these questions for several years. It's very difficult, and I don't think, the way that Unreal is built right now, Epic Games could probably modify it. It might not necessarily right now be meant to even be able to inject that inside. And so I wanted to show this example because this example, I think, is kind of like what the team has been doing, and it wasn't really shown that heavily because, well, what happened is that Microsoft Build during the summer coincided with the tragic event in Uvalde, so Microsoft didn't want to be like, hey, let's promote our products when there was like a tragedy going on in the US, which I think is good because it's ethical. But then this was sort of, this whole thing was overlooked and then attributed to other companies when it's like, no, it had already been done. And I just want to state, just because of the Microsoft thing, I would say, and I think now everyone should be aware of that as of last week when you saw Satya and Zuckerberg like talking together at Connect, Microsoft's sort of in a unique position because I think it's been under the radar because Microsoft actually invested $1 billion in OpenAI, and because of that has sole discretion to the underlying model. So actually, it was crazy, but actually in August, I actually got to meet with Sam Altman and like show him something similar to what I'm showing you. But again, that's like way off from like what actually is being able to be done now. And so the thing is, furthermore, not only does Microsoft reserve access to GPT-3's underlying model, but it also clearly has subsidiaries and studios like Xbox, right? Mojang Studios with Minecraft, which is where you'll see the assets are being pulled in the next example. But also, it soon is going to have Activision Blizzard, which is a whole repository of assets, right? And then it obviously has HoloLens and then Babylon.js, and so there's a whole like metaverse suite that I think is very understated. And so in terms of this OpenAI Codex FrameVR Babylon.js, what this is, and this was actually a project that Jaron came up with in like the 1980s, is like the ability to speak the world into existence. And yeah, this isn't as like, I guess like sexy or whatever because it's in real time. So I just want people to note that. But this is what's, and I would recommend people go to the blog link. I'll post it when AWE posts it.
So let's wake this thing up. Want to kick it off, Yura?
Sure.
Oh no.
Okay,
lag.
Frame. Bring in a model of the Earth. Make it spin
no.
and move it up 20 meters and backwards 40 meters.
Oh, come on. This is why the metaverse is gonna, no. Oh man, I might just show you on my computer. Really?
This uses Azure Cognitive Services for speech
he asked
recognition.
for a world to be spun. The video was
And
laggy.
look, we can actually see the Babylon code being generated by Codex as we speak.
Yeah, so that was that example. And so I was actually brought on to work in Unity since they wanted some implementation and solution for that. And this is still ongoing, so be gentle. We're trying. And so this is sort of like the equivalent that we've been working on. I might have to sort of explain it, but I'll explain it as it's going on.
Pull.
So what this is, I kind of wish I can pause it. It's fine.
Pause.
What this is it's a multiplayer ping pong game. It's using a lot of stuff. Oh, wait for this, and then I'll explain it after. So it's a multiplayer game in VR using speech, and it's also using Ultraleap. So if anyone's from Ultraleap is here, I saw them outside. We did use your IR sensor. And then I'm able to change my hand into whatever object I want, and then I'm able to change the ball into whatever object. Okay, and if you notice, basically, the game is sort of like a sword in the stone type game where you combine objects and they create other objects. So if you take a banana and an orange, you combine them, then you get a smoothie as the ball. But why I chose this one, because I thought it was funny, is I chose a racket and he chose an apple, and when they collided, they made an apple pie, which kind of confirms my theory that Codex is prioritizing texture, right? Because on top of apple pies, they have those netted textures. So no, there's some really funny ones. There's one where he generated a memory and then a collision, then it made PTSD. I'm like, what kind of? No, there's some very very interesting ones that GPT-3 is creating. And so this is these are like initial experiments. I can just skip to the last one because who knows how long this is going to take.
Create dog.
Okay, yeah. I don't want to end the present. Hold on, let me.
Create dog.
Okay, yeah. That one's kind of boring.
Create dog.
No. Okay.
Create floaty flamingo.
Yeah, this is the one I just did in the bathroom, which is kind of
Forward.
embarrassing. I just did it in the bathroom upstairs.
Rotate. Rotate. Create beach chair. Left. Create beach chair. Rotate.
And I'm mad that it spawned the same
Rotate.
one, but I don't have control over that. Because it could have tried to make a different chair,
Smaller.
but it didn't.
Right. Right.
Because I just wanted to play around with scale. You can try it out, actually. It's on the... So to prove that it actually works, right?
Create coconut tree. Bigger.
I think you get the point. You can basically do this with any sort of...
Forward.
You can basically call any object you want, and it'll make
Forward.
the object... Now, if it looks good, whatever.
Down.
But you can call any object.
Bigger.
Okay, there was like 5 more minutes of footage but I don't think we need to get there. And so yeah, let me wrap this up so that, for questions. And so I think where we are in terms of a holodeck is that we have asset and scene generation by models, and we have very rudimentary animations. But the problem is, just like in physics, what matters is like the actual interstitial interactions, so the way that objects interact with one another. And that's what we're working on right now, is like making sure that the objects animate with each other. Because they need to be able to interact both mechanically and semantically. And it's a really fascinating area of research. And we're slowly getting there, but this was a more realistic thing of where we are with real-time generative 3D in XR. And so this is a really lame art history joke. But I feel like we need to move from DALL to Bernini. So right now we're at DALL, but we need to get to 3D as well. And so I do want to end by saying that my mom always said that she wanted me to be a doctor, and she was confused why I'm an engineer. She actually told me, like 3 weeks ago, that she's mad that her only daughter's a nerd who talks to computers. But one thing that I always tell her is, like, being a nerd allows me the ability to work on this sort of stuff. And then maybe one day I can construct her own virtual reality where I'm actually a doctor in her scenario. So also, it's her birthday, so happy birthday, Mom, and I love you. And thank you to family, friends, colleagues, mentors, and AWE organizers, and enjoy your time at AWE. Yeah. Oh, I also wanted to thank Avi as well, who's in the audience. So yeah, it's Avi. copy.
All right.
Yeah.
Unfortunately, we do not have time for questions, but go ahead and search Jasmine in the event and ask away. Thanks, Jasmine, for this amazing presentation.